All right, we're going to go ahead and continue with complex numbers. They're asking us to consider the number 5 plus 2i. That's what we would consider a complex number because the 5 is a real number and the 2i is a pure imaginary number. They are not like terms. They cannot be combined. But whenever you see something in the form of a plus bi, that is what we call complex. And then I'm actually going to write it right here. So this is your real part. This is the imaginary part. Now, think about it as I being a variable. Now, if I were to tell you, hey, this is 7 plus 3x, and I said, can you combine those? Okay, the answer would be no. You cannot combine those. But the moment I add an x for the 7, then this turns into a yes. Okay, so keep that in mind. Same thing, if I were to give you something like this, 7x squared plus 3x, can we combine these? Again, the answer is no. But the moment I give that x there a squared, then this answer turns into yes. Okay, so just that's what you need to know for this lesson. So let's look at the number 1. They're asking us to simplify the expressions. Final answer must be in the form of a plus bi form. That means that your bi has to be the second one or the last one, or the only one if that's what you have. So we're adding and subtracting complex numbers. So if you look at this one, technically the number outside of this parentheses, we normally don't write it, but I'm going to for this example. So it's typically a 1, unless it's a negative there. Now if you keep looking over here, this is plus this. When you have that, you're technically distributing a positive 1 there. Okay, so the only reason I'm writing it is so that you guys can visually see it. So now when I distribute this positive 1, I'm left with negative 11 plus 3i. I just got rid of the parentheses. That's my purpose for this. I'm going to distribute this positive 1 again, and I'm going to be left with positive 9 plus 2i. Again, I'm eliminating those parentheses that I don't need anymore. Now I'm going to go ahead and take a look at this and see, okay, what is it that I can combine? Negative 11 and 9. Those are real numbers. I can combine those two. That's part of my A format. So negative 11 plus 9, I'm going to be left with negative 2. Now, plus 3i and plus 2i, those are like terms because they both have one I. There's no exponent here that we're going to have to worry about. So I'm left with plus 5i. Notice how it's in the form of a plus bi, like we had over here. So then you would be done. Okay, so we would be done with this one. So go ahead and do number 2. I need to see your work. Do not just write the answer. I already gave you the answer, so that does not count. You'll do 2. I'm going to help you get started on number 3, and then I will help you do part of 4. So for number 3, same thing. Remember I said pretend to see, okay, what number is outside the parentheses? This is technically a 1. You're going to distribute that. Then for this one, this is where it changes a little bit because it's actually a negative 1. So you're going to be distributing a negative 1 for this one. Okay? So kind of watch out for that. So now let's look at number 4. So same thing. If I look over here for these set of the parentheses, I am not distributing the 6i. I am actually distributing this negative here that you see. So I'm going to go ahead and put a negative 1 there. And then I'm distributing a positive 1 here. So I'm going to be left with 6i because I didn't distribute that or I didn't do anything to that. So now negative 14 plus I plus 5 negative 3i. All I did here was distribute. So negative 1 times 14, negative 14, negative 1 times negative I is going to be a positive I, and so forth. So now from here I'm going to go ahead and combine the like terms. I'm going to notice that I can combine 6i. So I can put 6i, I, and negative 3i. So 6i plus I is 7i. 7i minus 3i is 4i. And then negative 14 plus 5, that's going to give you negative 9. This answer would be wrong because I have to write it in the form of a plus bi. So I need to make them switch. So it's going to be negative 9 plus 4i as your final answer. And then you're done. Alright, let's go ahead and move on. Okay, for the next one, multiplying complex numbers, again, you need to remember that whole I squared equaling -1. This is why I said you need to understand how those patterns work because they are not going away. So for number 5 through 8, they're asking us to simplify these expressions. Now we're multiplying. We're not adding and subtracting them like we were doing for the first 4 examples. Your answer again must be in the form of a plus bi. We have that there. So I'm going to go ahead and do 6 with you. Okay. Number 5, you have 2i. You're going to distribute that 8 to the 8 and the -3s. Okay. But I'm going to go ahead and do 6. So on the 6 outside, I have a -i. So I'm going to actually distribute that -i to everything inside of the parentheses. I'm going to be left with 2i because it changes it to a positive, and then minus 10i squared. The squared comes from I times I. Remember that you add those exponents, you're left with -10i squared. Now, you have to remember that you have your I squared here is equal to -1. So anytime you have an I squared, you can actually swap that out for a -1. They're equivalent. So this is actually 2i minus 10 times that -1. So if you want to put like a little multiplication here so that you know that you're multiplying. So now -10 times -1 is actually going to give you a positive 10. So you're left with 2i plus 10. But this is not in the correct format because you have to write a and then bi. So I'm going to write it as 10 plus 2i and then you're done. Okay, so now we're going to go ahead and take a look at number 8. I'm going to do this one. So now notice how right here, they're right next to each other. That means that you're multiplying these together. If there was a plus sign or a subtraction sign like there was on 1 through 4, then you would not be able to distribute and FOIL these like we've been used to. Okay, so the fact that, again, there is nothing there that implies multiplication, that's really important for us to take that away from that. So now the 2, I'm going to distribute the 2 to the -5, that's going to give me a -10. The 2 to the -3i, that's going to give me a -6i. And then I'm going to do the same thing with -4i. So that's going to give me a positive 20i and then a positive 12i squared. Notice how that's a squared there. I'm going to combine like terms. So now the -10, I cannot combine with anything. I'm going to leave it alone. The -6i and the positive 20i, I can combine. I'm going to actually be left with positive 14i. And then we're left with 12i squared. But remember that that 12i squared is the same as earlier. Hopefully you know by now. It's a -1. Okay. So now from here, I'm going to multiply that 12 times the -1. I'm left with -10 plus 14i minus 12 because I multiplied them. Notice how once you did that, there's more stuff that you can now combine. So we have that -10 and the -12 that can actually be combined, even though earlier it looked like they couldn't. So I'm going to add these up because they're both negative. I'm going to end up with -22 plus 14i, and I'm going to double check, is it in the form of a plus bi? It is, and now I'm done. Okay, so keep that in mind when you're doing these. All right, let's go ahead and move on. So for number 9 and 10, I'm going to help you start off 9. I'm not going to do it. And I'm going to help you start off 10, and I'm also not going to do it. So for number 9, remember 6 minus 2i squared. Anytime you have something to the squared or to the second power, that means that you have two of the exact same things. You could actually rewrite this as 6 minus 2i times 6 minus 2i. The reason that it's times is because you're squaring something. If I did 4 squared, that's 4 times 4. So from here, you're going to do the same thing, 6 times 6, 6 times -2i, and then -2i times 6, and -2i times -2i. And you'll FOIL that from there, check your work, show your work. Let's look at 10 now. So for number 10, notice how these two here, you're multiplying these two, you're FOILing these to each other. But now over here, it's not the same thing anymore because this is not a multiplication sign, it's actually a subtraction sign. That implies that there is actually a -1 here that needs distribution. So I'm going to go ahead and do these two first here, and then we'll move on to the next section. So I'm going to go ahead and distribute. I'm left with 9 plus 3i. Then I'm going to do the next part. So plus 63i plus 21i squared. Okay, so that again, whoops, I missed the 21. Now, again, I already just did that first part. I have not done the 4 plus 2i yet because I wanted to do that after I foiled so that I didn't mess up somewhere. So now let's go ahead and do the -1, and I'll do that in a different color so you guys can see. So now I'm going to distribute this -1, which is going to be -4 minus 2i. Now everything is still together. I just did it by different parts. I'm going to go ahead and take a look at this and figure out what can I combine. So I'm going to look and see, okay, I can combine the 9 and the -4. That's going to give me a 5. I can also combine 3i, 63i, and -2i. So I'm going to end up with 66i minus 2 is going to end up 64i, so positive 64i. Okay, so again, I'm combining those like terms. And then I'm going to be left with the plus 21i squared that has nothing to combine with. However, the I squared turns into a -1. So I'm going to multiply that by a -1. So now I'm left with 5 plus 64i minus 21, which again, now I have something else to combine. That's my goal, because your answer has to be in the form of a plus bi. If you don't have it in that form, you're doing this completely wrong. So now let's go ahead and take a look at this one. 5 minus 21, that's going to give me a -16 plus 64i, and then you're done. Okay, so check your work. I gave you the key, so please stop giving me stuff with the wrong answer and ask me. Let's take a look at number 11 and 12. So these are kind of like the fun, easy ones if you remember this. So we call them the complex conjugate. So it says when you have a plus bi and you have the same thing again, but this time it's a subtraction, so a minus bi. These are called complex conjugates. The product of these conjugates are always a real number. And those of you that actually paid attention to the vocabulary and didn't just copy it down, a real number is something that is obviously not an imaginary number. So we have two different classifications. On the next lesson, I'll go a little bit more deeper onto what that chart that you guys filled out with the vocab represented. So for a real number, for example, if your answer ends up as 4i, this is not a real number because the I is imaginary, which means that that cannot be true. So anytime you have something in the form of a plus bi and a minus bi, so if you look at number 12, these are the same exact numbers, 5 and 4i. 5 and 4i, the difference is that one's a plus, one's a minus. Anytime you have something that looks like this and you go ahead and foil it, your answer will be a real number, meaning that there should be no i's left over in your work. So now I'm going to go ahead and distribute this. I'm left with 25 plus 20i, negative 20i, and then minus 16i squared. Looking at this right now, none of this is real from here. None of these are, except for the 25, everything else, none of it is real. So I'm going to go ahead and continue simplifying this. So I'm going to be left, if you notice, the 25, I can't combine with anything. The 20i and the negative 20i combined, they go to 0. And there is nothing for me to combine with this. So I'm just going to bring it down here. But the I squared, again, it is a -1. So technically this is 25 minus 16 times a -1. And 16 times a -1 is positive 16. You're left with 25 plus 16. I'm going to go ahead and add these together to figure out what my final answer is. And if my answer is not a real number, that I can already know that there's something wrong. If you add these, you're going to end up with 41. Now notice how there is nothing else with that 41. There's no I that indicates imaginary. This is how I know that I've done this correctly. So when you do number 11, if your answer, as soon as you've done all your work, it doesn't turn into a real number, then the complex conjugate, for that one, you're going to do it wrong. Okay? So let's move on. This is a little bit of a long video / lesson. Alright, so now dividing complex numbers. So the I, whenever you have an I, you that can never be on the denominator. The denominator means down. It's at the bottom. So if the denominator is a monomial meaning 1, you're going to multiply the top and bottom by I. If the denominator is a binomial meaning 2, you're going to multiply the bottom and top by the conjugate. So let's go ahead and take a look at number 14. So both of these, this right here, this is one term. This is a monomial. This is a monomial again. Okay, so both of these are monomials. So when that happens, I'm going to go ahead and use this right here where I'm going to multiply the top and bottom by I. I'm going to be left with 4i over negative 9i squared. But I hope we remember that the I squared is equal to negative 1. You have to remember this. So I'm actually going to be left with 4i over negative 9 times negative 1. That's 4i over 9. The 4 and the 9 cannot simplify. The I cannot simplify anymore because I don't have I squared, which means you are officially done. That would be your final answer. I'm going to go ahead and do number 16. So again, looking at, you have to pay attention to the denominator. On 16, the denominator, this is a monomial. The way that I know it's a monomial is because there's no plus or minus separating anything else. So for example, this is a monomial, mono. This right here, 28 minus the 8i, this is a binomial because you have 2 terms. The denominator here, though, is still a monomial, which means you're still going to multiply the top and bottom by I here. For 16, look at the denominator. This is a monomial. This is a binomial, but it doesn't matter because they're asking for the denominator. So because my denominator is a monomial, I'm going to multiply by I, the top and the bottom. So I'm going to go ahead and do that. Now, for these, it's kind of tricky because when you have a binomial at the top, you're multiplying everything by I, which means you're going to be left with negative 8i minus 2i squared. And then at the bottom, 6i squared. Now, this looks kind of messy, but you'll be able to clean this up a little bit. Remember that the I squared is always a negative 1. So I'm going to be left with negative 8i minus 2 times negative 1 divided by 6 times negative 1. Then you're going to simplify this. So I'm left with 8i minus 2 times negative 1. So that's going to be positive 2. And I'll rewrite it in the form of a plus bi because that's what you always want to write it as. So I'm going to write it as 2 minus 8i. And at the bottom, I'm going to have negative 6. Now, if you write these separately, you can actually simplify them. So for example, if I were to, I'm going to actually erase some of this so you guys can see. So if I rewrote this as 2 over negative 6 minus 8i over negative 6, I'm going to simplify that. This is going to end up being negative 1/3. And then I'm going to end up having the plus. We're going to have 2 going into both top and bottom, which means that your final answer, once you rewrite it, will be negative 1 plus, negative 1 plus 4i over 3. Alright, so let's go ahead and move on. When the denominator is a binomial, you're going to multiply the top and bottom by the conjugate. So 17 at the bottom, the denominator, this is a binomial. So it's 5 minus I. The conjugate, remember, it's 5 plus I. If you don't know where I'm getting that from, look above on your notes when I talked about the complex conjugates of a plus bi and a minus bi. So because this is an a minus bi, your conjugate would be a plus bi. You're going to multiply the top and bottom by that. Okay, so I'm going to go ahead and distribute this negative 2. I'm going to be left with negative 10 and then minus 2i. The next one, remember this is a minus bi times a plus bi. That means right here, when you multiply these, you better end up with a real number. If you don't, you did the bottom completely wrong. So 5 times 5 will be 25. 5 times I will be 5i minus 5i minus I squared. I just FOILed it right now. I'm going to go ahead and clean this up a little bit. Negative 10 minus 2i. Notice how these cancel. I'm left with negative I squared. So this is 25 minus I squared, but the I squared is negative 1. So that's actually a negative times a negative 1, which will be a positive 1. So 26. Now I'm going to separate these two so that I can be able to simplify them. Okay, so 10 and 26, they'll simplify. I'm going to be left with negative 5 over 13. And then the other one will be I over 13. You can combine them to have negative 5 minus I over 13. Okay, I'm going to go ahead and do one more with you, number 18. I'm going to multiply the top and bottom by the conjugate because this is a binomial. So a minus 2i, 6 minus 2i. Again, because the conjugate is where you make one positive, the other one negative. I'm going to go ahead and distribute everything. I'm left with 30i and then minus 10i squared. So you will have to simplify some stuff. Now notice again, it's a plus and a minus. That means that your answer better be a real number. So real number. So 6 times 6 is 36, and then we're left with negative 12i, positive 12i, negative 4i squared. Notice how these cancel again. I'm on the right track. Now I'm going to simplify everything else. Now the I squared turns into a negative 1. So 30i minus 10 times negative 1. That's just going to give me negative or positive 10. I'm going to just skip that step. And then 36 minus 4 times a negative 1. Okay, that's going to give me a positive 4. So I'll show you here what I did so you can kind of understand where did I get the other numbers from. So now from here I'm going to be left with 40. And I'm going to rewrite them separate. So 10 over 40, I'm putting my a first, plus 30 I over 40. Okay, I'm going to simplify this. I'm left with 1 over 4 plus 3i over 4. And I can combine these because the denominators are the same. So 1 plus 3i and then 4 at the bottom.